Okay, welcome everyone. Welcome back to the third Python tutorial of this series. So hopefully everyone who is watching has already watched the recording from our first two sessions where we have set up our workspace, which includes downloading a text file. And then in the second session, we began to parse that file into a list of strings. Today, we're going to continue that effort and restructure our data into a dictionary, which we are then going to call up in our first ever function. So my name is Julia Kent. I work here at NCAR in part of the Earth System Data Science efforts and Project Pythia. And I'm generally doing a lot to help make scientists more equipped to use software engineering tools that solve these big problems. So thanks for attending this tutorial and contributing to more open, more reproducible science by using Python. Before I begin, let's review the code of conduct. By joining this call, you've agreed to engage in respectful communications and adopt these values. Any inappropriate remarks and you'll be removed from the call. And of course, if you need help, feel free to ask in the chat. A co-host or myself might be able to assist you. It's also possible that some of your questions will be tabled for the end of the seminar or even a separate one-on-one meeting, depending on their immediate relevancy to what we're working on right now and the audience. How many other people in this room need to be there for that discussion? So thank you for asking your questions, for going deeper, and for making sure you're not getting left behind. So thank you again, and I'll do my best to find this good balance. The commands are on the website, and I'd also like to direct you to Stack Overflow and Project Pythia as some other great learning resources. And today, the function that we're going to be writing, just a brief overview here, is we're going to estimate wind chill index with this very simple equation here of temperature minus 0.7 wind speed. This is just an approximation, which we'll maybe talk about more later. Our point here isn't to teach you atmospheric science, but to teach you coding, and we want to use atmospheric science examples. So we'll do some more advanced computations as we go forward, but we're going to lay down the groundwork for understanding the syntax and everything involved in a Python function today. So first, let's pick off where we left off. Everybody open your terminal. Give me a second to transition here. Okay. Let me full screen that. Is the font large enough for everybody? Here. I wish I could move this bar. Okay, well, I'm going to move into my documents directory and then move into the folder where you are keeping this project that you are working on. So for me, it is Python tutorial _22. You can double check that you're there, see that we have everything. We have a script, we have our data folder, and also very importantly, do not forget to activate your environment. Conda activate Python tutorial 22. Okay, and you can see that's activated here again with these parentheses. And let's take a look at our script and remind ourselves what we've done. Again, I use nano, and then the name of the script. Okay, so we have initialized a data variable as an empty list here. We have our file name variable that points to our data path. And then we have a with block that contains two for loops. The first one loops through the header reading the file, and then the second one actually reads each line, splits them on white space, and adds them to our data list. So we now have a list of strings, and each list is a time stamp within the data for each variable in our file. And these are all strings again. So ideally, we'd want this to be, formatted differently. You'd want to be able to call all temperature data instead of calling all data from one time. So we got to do a little bit of data manipulation here. And I'm going to go ahead and change data from this list with the square brackets to a dictionary. And that actually looks like curly brackets. Dictionaries are like lists in that they're changeable. So you can add to them, you can append them, you can, well, I don't know about the actual append function, but you can change them. They can grow as your computation grows. But most notably, they are unordered. There is no first index or second index of your dictionary. Instead of indices, you have keys, which point to their elements. And these keys are more human readable generally. So instead of saying, oh, I have to remember that the first column is date and the second column is temperature, you can just say, I want to call up date and temperature. So that's really great. And hopefully that's something that'll help your computations. But we're actually going to use lists inside our dictionary. So our first key is going to be date. And that's going to be an empty list. And then we're going to also pull out time and initialize that as an empty list. So these colons are what map our key to the data that they point to. And right now that data is type list empty. There's nothing there, and we will append it as we go through. And you can do this all on one line for your dictionary if you'd like to. I'm just doing this. It's more readable than when the line gets really long. Okay, and then we also have our temperature out. So just like a little note here, keys act very similar to indices. So how before you would have a list and you'd pull out the 0th index, here you're going to have a dictionary and you're going to pull out the key like that. So this is going to look like data temp out. And this is just in a comment here for me to just kind of explain that as I talk, but we're not going to execute this part of the code. Okay. So something you might notice is that these square brackets in Python are both used to declare a list, to say that something is a list, and it's used to get an item from your object. So that item can be from your list, but it can also be from a dictionary. So I know that can be maybe a little confusing, that dictionaries are set up with curly brackets, called with squares. List, you use squares for both, for setting them up and for calling them out. So it's slightly different, even though it's the same character. Another difference between the two is that slice notation, like the indexing we were doing, only works on lists. So when you say like we want from 0th to 1st or 0th to 10th index, you can only do that on a list, again, because the dictionaries are not ordered. Let's see. Yeah, that's mostly what I have to say about dictionaries for now. And then we're going to go down in our code here. I'll leave this comment at least for now so people have time to look at that. Here, instead of appending just data, I'm going to go ahead and delete this line. You can do that with Control K for those of you who want to know. And then we're going to indent 8 spaces in line with datum. And we are going to do a similar syntax where we append the list with the value, but so it's data, date. So this is now pointing to our currently empty list, and then we can append it. And the value we're going to append it with is the first column from every single line in our for loop. So that looks like our split line, which is itself a list again, and then the 0th index. And we're going to call out time and temperature as well. Yes, Kevin, thanks for pointing that out. Hash maps or something similar in a different language is essentially what the dictionary is. It's a hash map. Okay.
And Julia, before you get too far in there, here that split list doesn't exist.
Oh, split line. Yeah.
It's called datum.
Oh, wow. Thank you. I'm not sure. So I have discrepancy between my notes and what we've done so far. Okay. Datum. Okay. Okay. And one more line. Come out. Okay, so I just happen to know, I remember that our header goes date, time, temperature, and then everything else. You can double check or remind yourself what it is by printing read line. So maybe we'll just do that right now to just kind of see. And we're gonna also, first, let's just run this and make sure that it works. Okay, and I'll do that again with Control X, save, and then Python mysci.py. And we can see our header. Again, the formatting is a little difficult to look at because it's my font size is larger than my screen, but you can see that we have date, time, temp out. And then we have high temperature and low temperature, humidity, dew point, etc. Okay, so back into our script, if you can remind yourself that this is 0, 1, 2. We no longer want to print this. We're going to add a debug section to the end, again with a hash mark, debug, and we're going to just print a few things to make sure that our data dictionary looks the way we expect it to and can be called the way we'd expect it to. So we're going to print data temp out. So this should go into your data dictionary, grab the list that is temperature, and then if you want to also pull out a specific timestamp, you'll do that with the indexing. There's other tools in Python that will let you pull it out by what's closest to the certain tool, to the certain date, things like that. Since we're just using pure Python, the simplest thing we can do right now is just with the index. So that's going to look like this. And I'd also like you to print the type of the data. So you can print type, maybe time. Oh, I am missing a parentheses here. And at the end. And maybe also maybe print a type of our temperature data, something like that. Okay.
I think you need one more parentheses.
I do. The exact same as the line before. I have to close the type function and the print function. This is a syntax error that I encounter more often than others sometimes, is just getting the correct number of parentheses. Luckily, when you have that kind of syntax error, a lot of times Python can tell you it's on this line, and I know to just look at the end of the line and count my parentheses. It's one of the more common syntax errors, I'd say. So exit and run this new code. Okay, so we have our data, that's 71.1. And then we have our time type, which is just a list. It's a list of all of our times. But you might not know from printing our temperature data that this is actually still a string. It is not, Python does not read this like it would read a number. It reads it the way it would read just a series of any characters. So let's clean up our code and do some Git commits for this part of the of today, and then I'll wait a little bit and take some questions before we move forward. So okay, so basically we just don't need to print these lines anymore. Let's see, okay. And then we're going to do a git add mysci.py. If you remember, you can check a git status. We have one modified file and a git commit. This time our commit message will be parsing select time series. Okay, I'm gonna do a git log here, and you can kind of see the history of all the steps we've taken so far in the tutorial. Okay. Yeah, if you are ever working with a dictionary that you yourself did not build, you can find out what all the keys are. I will do that again down here, just to demonstrate. Add back in the debug section, as long as it's not in our git commits, as the idea. So if we want to print our, we'll call it keys, will be our new variable, and you can call that by getting a list of data, because that's the name of our dictionary, .keys. And then just go ahead and print keys, and we'll make sure that this worked. Oh. Done. Okay, so we have date, time, and temp out. Okay, so now what we want to do is, yeah, so you don't necessarily have to call this, but that makes it so that you can maybe work with it in a way that's a little bit more familiar with to you. We're going to go and fix our temperature data so that it's no longer a string. We want it to be something that we can do some math on, do some science. Okay, so the way to do that is here. When we append our line, datum, second index, we're actually gonna just call float on it. Like so. So this is a new data type for us, the float data type, and it refers to floating point real values, which is basically the data type of any number that has values after a decimal point. So just not an integer, really. You could also change this to int if you wanted to, if you wanted to round out the values, but I don't think you can go from the string to the integer. Okay, now you cannot turn any object into any type. So we can try this in our debug section, just a little examples of this. So I'm going to delete these 2 lines. And let's try float of the word, I don't know, error, because we might get an error there, because it's that's not going to work, right? And similarly, we can't turn that into an integer. But let's test if we can turn our string that is also a number into an integer. So we'll do that by calling data, temp out. I'll just say 9 again for consistency. Okay, so we have to close integer and the print statement like that. Okay, could not convert string to float. That makes sense. Something I also briefly forgot about is that once it gets to an error, Python is going to stop running the code. So it's not going to show us that these other lines did not work. Again, there's ways around that, but they use external packages. So this line, we know we can't do that. Check that off, delete it, and we'll just run this 2 more times to check the other lines. Okay, we cannot turn a random string into an integer as well. Let's find out about the last one. And it worked. It just rounded our value from, was it like 71.2 to 71? Okay, so that's great. Let's clean up the code again and do 1 more commit. Okay. Git add and then git commit -m. Converting temp out to floats. All clean. Okay, so what we have right now is great. We have our data in strings. But it's a little complicated if you wanted to go and add and get more data columns out of our file. You have to change our code in, I think, 3 different places, or at least 2 different places. Let's look at it. Okay, so you'd have to change it here when you initialize the data dictionary, and you'd have to change it again here where you append the lists within your data dictionary. There's definitely a cleaner way to do this and to reuse our names, our keys here. Oh, yes, when I cleaned it up, I said I was going to delete this comment, and I did not do that yet. Okay, so that's just 1 step here. What we're going to do is actually create a columns. We're going to create 2 dictionaries that we then use to build our dictionary. So we're going to call it column names and column indices. So here we have date, which maps to 0, time, which maps to first, and temp out, which maps to second. And then we're also going to create a second one for types, so that if you want your data to convert to a float, we'll be able to do that a lot easier as well. So we're going to call it data types for each column, if non-string. We're going to set this up in a way that you don't have to specify if you want to leave it as a string. You only have to specify if you want to change it. So types equals our key temperature, temp out, and it's going to be a float. Like so. Now, actually, for best practices, you want a space here between your colon and your value. Again, this is not going to break your code. It is just generally considered easier, more readable, especially when you start having larger workflows. Okay, so now we have to change our initialization of the data variable. This is an important step, right? We want to actually use these new folders, new dictionaries. So here we call data. I'm gonna delete these lines here. We just initialize it as an empty dictionary, like we did in the very beginning. And we're going to create a for loop. So for column, in columns, indent 4 spaces. And then we initialize that column's key to an empty list within our dictionary, like so.
It's not a colon, it's an equal sign.
Oh, yes. Sorry, I was looking at that. I was like, something's wrong. Okay, so the colon works inside of the dictionary notation. Here we are creating the new variable data column, and we have to set it equal and initialize it as an empty list. So this colon notation, again, only works when you're already within the curly brackets. So this line right here is more likely how you're going to add keys to a dictionary after you've already initialized it. And oftentimes when you initialize, your dictionary might look more similar to something like this. Okay. Okay. So our value here, we have our data in that split, the correct indices. We want to go ahead down here and change that as well, I believe. See if I can find that. Where? So here within this for loop, we keep our datum, our line split, and we're going to go ahead and delete these lines, and we're going to replace them with another for loop where we loop through our columns. So for column in columns. 1, 2, 3, 4. I for index, because that's what each column points to. We're going to do columns dot column, pull it out, and we'll do T for types. T equals types dot get column comma string. So this works. Well, I guess we'll start with this one. We go into our columns dictionary and we're looping through date, time, and then temp out. And so we get the values of 0, 1, and 2. For types, we check our dictionary with the .get method. So we're checking it for date. We're checking it for time, and we check it for temp out. And when we check and it's not there, we give the value as a string is the type. And when it is there, the value is whatever it points to, which is going to be a float. Okay, so James, you're saying the syntax seems a little arbitrary. Okay, let me see if I can try to clarify it. So you use the equal signs when you are initially defining something. And then the colons here are more for mapping, I guess is how I'd say it. So it would definitely be confusing, you can imagine, if you said columns equals a dictionary where date and you reused the equal sign in that same line. It would definitely, that would be confusing. I think you can only have one equal sign per your line. Well, technically, if you have two equal signs next to each other, you're checking if a value is equal. But other than that, you can only really set one variable per line. The colons here are more of defining the shape that our dictionary takes. So our dictionary here equals columns, and then columns has dates mapping to 0, time mapping to 1. I don't think you'll see this colon notation really outside of dictionaries or outside of other data classes that inherit from dictionaries. Okay. And the periods that you talked about, again, they're for accessing methods and functions. So then you're saying, I want to call up something that can be called on this object. You'll do it with the dot period notation. Okay. Okay, let's go back to the end here. We're gonna create a new variable called value, and this value from our list here, or for our data, is going to be the type of datum at the index that we're looking at as we move through the column. And we are then going to data column. So whichever column we're currently in, we then go to that column in our dictionary and we append our value, and it has already been updated to the correct type. So again, we're going through the file, we're reading every single line, and then in each line, we read column 1, column 2, column 3, read the next line, 1, 2, 3, and we just are incrementally appending all of our lists within our dictionary, like so. Okay. Let's make sure that still works. Okay. Go back in. Okay. So maybe we should actually do a git commit right now. Git add mysci.py git commit -m refactoring our data parsing code. Yes, so you'll see down here, T is pointing to our data type, which is going to either be a string or a float. And these data types also are a method here. So we're pointing to the function called float that turns the arguments passed into it into a float, or turns them into a string. If they're already a string, it's not going to do anything. So yes, T here is a function, and I here is an index, is an integer. Okay, so we are now going to write our wind chill function. So the first thing we need to do is grab more data. So hopefully that demonstrates that this was easier to do. Oops. I don't know how that got there. We don't want that character. So hopefully this demonstrates the value of creating our columns dictionary. So I'm going to go to the end of the file. You can do that with Control E for most of you for the hotkeys. And we need wind speed. And I can tell you that that is the 7th index. So you can just add it there. And we also need to pull it out as a float. Okay, so now our data dictionary, when it's initialized, when we run this function, is now going to have another key. It's going to now have the wind speed key, like pointing to an empty list again. Okay, and now let's go to the bottom of our code here, and we are going to create our new function. So that's going to look like def for define, name of our function. And then we are going to call it estimate wind chill. Here, you can call it compute. It's best to name your functions with the verb that, like the action that your function is. All of your functions are actions. And all of your variables are more like objects, like nouns. I used to, when I was first learning to code, I would name my functions almost the same way that I would name my variables, and it'd be sometimes confusing in the space, because say I would just call this function wind speed, like define wind speed, and then that variable I would output is also wind speed, and that can be less readable to your eyes and a lot more confusing when you go back. So I'm going to encourage you to name your functions with a little bit more characters in them to describe what's happening. It might take a little bit longer to do the literal typing, but it's definitely worth it. Okay, and so our wind chill, as you know, probably is a function of temperature and wind speed, which we're going to use the shorthand T and V for. You close your parentheses. So again, the parentheses are the arguments that your function takes. In this way, it does matter what order they're in. You're able to, when you call up your function, you're able to say like this one is T and this one's V. But also you can just enter one and then the other, and Python will know that the first one is temperature and the second one is wind speed. Okay, so then similar to our other various blocks, you're going to do a colon, down a line, indent 4 spaces. Wind chill index, WCI, equals T minus 0.7 times V. So this is our first math operator that we're using in Python. So most of them work the way you'd expect. Let me do a little colon here. So we've got like addition, subtraction, multiplication is the asterisk, a double asterisk like so, like that would refer to exponents, exponents like raised to the power of. And for division, you can do a backslash. We also have a double backslash, which is for integer division. So you just want the value returned as an integer. It would look like that. To get the remainder, that is actually the percent sign, like so. We can kind of show this in a debug section. Show like print 2 divided by 2, but also 2 integer divided by 2. Okay.
Maybe try 3 divided by 2.
Let's just try a few of them, right? Like that, maybe. Okay, but before we run our code, let's actually go and close out this function. So at the end of your Python functions, we are going to return any values that we want accessible when we are in the general scope of our workspace. So we're calculating wind chill index because we want to use wind chill index. Not all functions need to have a return statement, but some functions do things. Like if you had a function for reading the lines of our text file, that wouldn't return anything because it has moved us down the file instead. Okay, so does integer division operate only on the result or on the numerator and denominator first? Well, let's go ahead and run this and see if the answers are what you'd expect here. So okay. So our first one is 2 divided by 2, like normal division. We get the float 1.0. But when you do integer divide by 2, you get the integer 1, 3 integer divide by 2, and it is also the integer 1. But the remainder, again, is the integer 1. So maybe the difference between these values isn't quite, you know, they're all ones, but this 0.0 is a different data type in Python. Okay. As far as what's happening first, I don't know, maybe one of the co-hosts can put in the chat. I've never really asked myself that question. I just know what the expectant behavior is, like so. Okay. So I will also say that in Python, functions can be defined in any order. So you could call, you could just define all your functions. Some people like to put them in alphabetical order. Sometimes it's just the order you wrote them. But if you call a function earlier in your script than when you defined it, you will get an error message. Python basically looks through the whole script, gets to things. If it can't find them, it doesn't look past that. So the best behavior is to have some of your functions in a separate file that you then import in. And we'll cover this probably next time we'll get to that. Okay, so let's go back into our script and replace our debugging section here with some data output. We have to actually call up our function. Okay. Okay. Yes, I encourage you to play around and print out your own equations that look interesting to you. Okay, so to do this next part, we are going to introduce the Python function zip. And before I necessarily show you, I'm just going to kind of demonstrate what it does. It's like a zipper. So we're going to make an arbitrary for loop where we have I and j within a zipped a zipper of two lists, like so. We'll make one list longer than the other just to demonstrate some unique behavior. So the zip will take our two objects and combine them into one, in a sense. You know, I'm sure you've heard of zip files. And then we can say for I, which will point to the first part, and j, which will point to the second part. And just to show how we move through this, let's print I and j, just to see what we expect. So I'm going to tell you the first time we go through, it's going to print 1 and then 3. And the next time it's going to print 2 and then 4. And this 5 value that doesn't have a pair over here is nothing's going to happen with it. So let's go ahead and run that. 1, 3, 2, 4, like I said. So the zip function here actually creates a tuple, which is like a list, but it can't be changed. So lists and dictionaries can be changed. Tuples, once you set them up, cannot be changed. The value of that is that they're actually much faster because Python doesn't have to access them in a writable state within your memory. It can just read them. So that's nice. And the result of the length of your tuple is going to be the length of whatever the shorter element that you zipped together is. Okay, so back into the code, instead of zipping up some random data here, let's zip together our data that we need to call our function. Okay, so delete these lines. We have to first initialize wind chill as an empty list. Then we're going to say for temp and wind speed. And there's zip. So that's like saying for I and j, as we just said. And what we're going to zip together is our data with our temperature and then our wind speed. Okay, so again, this is going to create a tuple. Oh, sorry, spam calls. So this is going to create a tuple that has a temperature and a wind speed data that share the same date index. And we're going to have going to loop through this. So we're going to loop through each one of these. And as we do, we're going to call our estimate wind chill function on each pair. So indent 4 spaces, and then we append the list with our function estimate wind chill. And then it is temp and wind speed, which are like our I and J values from our for loop here. And again, here, like before, you need a second parentheses to close out this line, because you need to close both your function call and your append call, which is also a function. I meant the function we wrote. Okay. So some notes again on the scope of your function here. Say if we did like for t comma v in zip, call the function t comma v, that would still work. But in general, it's best to avoid namespace collisions by using t and v in 2 different ways. So one as the iterative value as we go through a for loop, and one as the value used within our function. Here in this case, that is okay, but it's important to be aware that if you have a variable defined within your function, even if you defined it out of your function, you will not be able to access that value because it's been redefined within your function. In the global space, it won't matter. So that's part of why we are using temp and wind speed, just to avoid the same name. Also because it is more readable when you look at it. You don't have to guess what these values stand for. So that's great. Also, the local variables within a function are easier on Python memory management. It's hard in Python for you to manually have some control over the memory. It uses more of a garbage collection system. So whenever there's like a cleanup that's called, perhaps you've reached a certain level or just some amount of time has passed, all of these variables that are no longer referenced will be removed. And so variables that are defined within a function but not returned would be some of these values that Python just doesn't need to remember anymore. Okay, why did I put in the zip? I use the zip to create a tuple. I want to make sure that I am mapping our temperature and our wind speed data from the same index as we move through. And a tuple is one of Python's main built-in data types. So I also wanted to kind of demonstrate that for you. Can you just send the data to the function? If you send the list data, like data temperature, into our function call, it wouldn't work because we need to do our math here. This math that happens on this line needs to happen to each float as we move through our list. And if you just do the math of like a list minus this times a list, that isn't necessarily gonna act the same way you expect it to. I'm sure you know sometimes like multiplying two lists by each other, just you get some like more complicated matrices when we just want to do the math on the values that are mapped together in our tuple. So that's why we are doing the zip function. It's a lot more, it's a lot cleaner. Yeah. Yes, and also if you had a different number of rows, it would still work. The extra rows in one of the columns would just kind of be dropped off. Okay, so temperature, I'm just calling temp for temperature. It's called temp out in our data file because we also have a temp high and a temp low, and temp out is the average of those two values. But we're just using that one. I've called it temp out here just to be consistent with our original data file. But temp here, we say for temp, and that's gonna harken over to our data temp out list. And wind speed then is iterating through our data wind speed list. So I named them differently intentionally, yes, because I do want to highlight that I want to highlight when things are not the same thing. So again, our temp here is an iterative float. It's not a list. And our temp out here, data temp out, is a list. Okay. Yeah, so once we are out of our for loop again, all the previous values of temp and wind speed are rewritten every single time. And so it's using less memory in a way. And again, at the end, all those old values just don't, they just don't matter once you've moved through your list. I hope that makes sense. Okay, so now let's do a debug section and let's print wind chill. See what that looks like. Okay, I think we've spent a good amount of time on this page, so everyone has the syntax down. You can see that our script is getting quite long. You can't see all of it on one page. You can only see half of it now. Maybe that is frustrating. And so I'm going to show you as we move forward how to refactor our code so that we don't have to kind of scroll up and down a bunch, be easier to read. Okay, but first, let's just check this out. Okay. Okay, we have a list. We have a list of values between 60s to 80s. They are all floats, and that means our function worked. Okay, so let's clean up and do a git commit now that we have everything working. Okay, go to the bottom of your script. Can delete our debug sections. Exit, and then do a git add and a git commit. Compute wind chill factor. Okay, great. Do a git log. Okay, I just noticed that it is already 2 o'clock. So I think we should stop here for the day. When we come back in 2 weeks on July 7th, I will cover using F strings. So that is like formatted strings in Python. So we can make our output a little bit more pretty than just all of the wind chill indices, varying degrees of precision displayed. So we're going to work on some F string formats, and then we're also going to compute heat index and compare our values to the values already in our data. You know, we're going to kind of move this a little bit more forward. So thank you again to everyone who came today. This will conclude the 3rd lesson of the tutorial. And today we, as a reminder, we saved our variables. We saved date, time, temp out, and wind speed in our dictionary. We use the data types, floats, integers, and tuples are all new to us today. So we've covered the four main Python data types, I believe. And we estimated wind chill. We used some new functions. We used zip. And for the first time, we refactored our code, which is huge. That means we cleaned it up and we made some changes that'll make it easier for us to restructure in our code moving forward, even though they weren't functional changes. So again, I'll see you again on July 7th. I'm going to stop the recording, but I'll stay around for some more questions that people might have.